We're standing here with Matt Reeves, who is the director of the archaeology program here at Montpelier. And Matt has a map that is the product of the resistivity work that Natalie talked about a little bit earlier.
Yeah, the map that we have right here, John, it's a compilation of all of the resistivity data. So Natalie might have explained that they're taking points every 2.5 feet. They're taking measurements of what kind of resistance the ground gives to the electrical current. And what this map shows is all those points mapped out, and then we've got a program called Surfer that interpolates between the points, but to produce a contrast map. And basically, the areas on this map that are shown as red and then also bright yellow are areas that are giving a very high resistance to the electricity. The areas that are in blue and also in violet are low resistance. And basically how we're measuring this is areas that have less moisture are going to give higher resistance. If they have more moisture, they're going to allow the electric current to flow easier, so it's less resistance.
So how does that resistivity factor into making decisions about where to excavate your units?
Well, what we found in the past with the resistivity, and this is what we're optimistic what might happen here, is areas that have high resistance tend to have, especially if you can see a larger pattern, typically have a stone pavement below the ground surface. So for example, in the front yard where there's areas of high resistance, we found the stone siding for the carriage road. In the south yard we found where similar areas of high resistance, there are stone pathways in the yard. And then the best example is over in the south yard where the slave quarters are. There was one spot that had very high resistance, and that's where the stone chimney base was. And what we're hoping in these areas is that some of these might represent areas where there's either a stone foundation, some kind of stone pavement below, maybe for like a dung repository associated with the stable, who knows. George Washington's Mount Vernon has something similar to that. But then what we're also doing is combining this data with the metal detector and shovel test pit data. Metal detector data showing where metallic hits are found, and then also the insurance map from 1837 that shows where the stable should be. And what's interesting about the correspondence of where the insurance map shows the stable and where this kind of hot zone is it's roughly corresponds. It's off maybe about like 30 or 40 feet. And that's what we tend to expect with the insurance map. It's not the exact location, but it gets us in the ballpark. So we've got to investigate it. I mean, one of the units that we opened up that you've been working on, John, I'm not sure what that the high resistivity came from, but you found quite a few nails, and then also an area of concrete removal from some of the bricks from the repair of the garden wall. Whether that's creating it, it's hard to say. So, oh, and then also maybe from, like Mark mentioned, who's over here to the right, he mentioned there might be results of a fire, but we'll have to see if there's any more reddening of the soil.
So the discovery continues, as do the reformulated hypotheses in this work.
Exactly. That's what archaeology is all about. Is you think you have it figured out, you open up a unit, and then you realize you're wrong, and then you try to figure out why you were wrong. And that's where the excitement comes in, is continually revising what your hypotheses are about the site, and then working it together to try to figure out the big picture.
All right. Wonderful for your comments, Matt.
Okay, thanks, John.
Yep.